welcome to Pre-Calculus. In this video, we're going to start looking at Chapter 10, Section 7, something called polar coordinates. Our bullet points are to plot points in the polar coordinate system. That'll be today. Tomorrow, we'll look at converting points from rectangular to polar and vice versa. And then we'll finally look at converting equations from rectangular to polar and back again. So in your math career up till now, we've always plotted a point with x, comma, y. So this red point, in relation to the origin, I could always block it off and make a rectangle. So the thing you've been using up until now is usually called the rectangular coordinate system to locate a point out in the plane. Another way to do it would be to find this distance, let's call it r. Our distance the point is away from the origin, r, comma, and then the angle here, the angle of elevation from the positive x-axis, would be our angle theta. So xy is old news, r comma theta is a new way to locate the same point. So to form the polar coordinate system in the plane, fix point O, call it the pole or the origin, and construct from that O an initial ray called the polar axis. So that's just our positive x-axis is the polar axis. Then each point P in the plane can be assigned a polar coordinate, r comma theta. R and theta are defined below. R is the directed distance from the origin to the point. 2, theta is the directed angle counterclockwise from the polar axis to the segment OP, that line that will take us to our point. So over here I have a unit circle. Notice we did not use the two closest. This would be pi over 12. Up here would be 5 pi over 12. But we do have our angles in the middle, the pi 6, the pi 4, and the pi 3. So let's try graphing a couple of these. I'll do the first one in red ink. So 6 means we're going to go 6 units away from the origin, and we're going to go on the pi over 3 trajectory. So here's pi over 3 in red. Or in blue ink, I'm going to go from the origin 6 steps. So here's 1, 2, 3, 4, 5, 6. So there's my red point for 6, comma, pi 3. So again, I went to the pi 3 angle, and I went 6 units away from the origin. The next one is 4, negative pi over 6. I'm going to do this one in blue. So here we are at the origin, or the positive x-axis. If we go up, it's positive pi 6. If we come the same distance down, this would be negative pi 6. And then we're going to go 4 units. So from the origin, 1, 2, 3, 4. Put my blue dot right there. Okay, last one I'll do in black ink. It's 5, comma, 11 pi 6. Well, in this one, we did negative pi 6. 11 pi 6 positive is the same place. So I would start here. I would go all the way around to 11 pi over 6. And then I would go out 5 units, which is just one more than we did for the last one. So that last point C is going to go right there. Example 2, multiple representation of the same points. Let me back up here again. Notice in all of these, they were all positive numbers. The first one, I went up to the pi over 3 ray, and then because it was a positive 6, I counted 6 units toward pi over 3. If this happened to be a negative 6, I would still go to the pi over 3 ray here, but I would go in the opposite direction. For the negative, I would go 6 units, and I would be down here. So when we account for that and the positive and negative angles, there are multiple ways we can represent these. So let's see here. Plot the point 5, comma, negative 3/4. I'm just going to rewrite it here. 5, comma, negative 3/4 pi. So positive 3/4 pi would take me to here. Negative 3/4 pi will take me this way. So we went clockwise 3/4 pi. So we're on the 5 pi over 4 ray, and we're going to go out 5 units. 1, 2, 3, 4, 5. Now we can represent this 3 more ways. The other one will also have a positive 5. We did negative 3/4 to go in this direction. Well, what angle in the positive direction would take us to the same spot? That would be the positive 5 pi over 4. 5 pi over 4. All right, the other two representations, we can do these with negative 5s. So what that means is we want to wind up across the circle over here. So if we can get to this red line, and then the negative number will push us across the circle. So one way to do it would be to take the easy positive root, positive pi over 4. And then our other option would be to go in a negative angle direction like this. That would be negative 7 pi over 4. Now I just happened to look down at my notes, and this is example 2. In your notes, this 5 here might be a 3. The book originally had it at 3, and I thought the points were too close to the origin, especially for this graph I found online. So I did change the 3 to a 5. No big deal. All right, I think we got a couple of checkpoints here. So you know the drill. Pause the video, try these checkpoints, then fire the video up and see if you got the same answers that I did. And let's see here. Yeah, in your notes, these lengths here will be a little different. I see a 3, a 2, and a 2. Again, with my graph, I like to go out a little farther. So I'm going to do the first one in red. We're going to go to 1/4 pi and then head toward it 6 units. So here we're going to go up to 1/4 pi, and then we're going to go out from the origin 6 units. 1, 2, 3, 4, 5, 6. So we're right here on the edge of that, right at 1/4 pi. Okay, next one I'll do in blue. Negative pi over 3. Here is positive pi over 3, so negative pi over 3 is going to be straight down below it. So we're going to come down here to 5 pi over 3, that's negative pi over 3, and then we're going to head toward it 4 units. 1, 2, 3, 4. Last one I'll do in black ink. 5/3 pi and 5. So 5/3 pi, we're going to go all the way around here. This blue dot was 4 units out. We just want to go 1 more unit out. So there's our final one, 5 comma 5/3 pi. Okay, now this one, plot the point and then find 3 additional representations. What I'm going to do is just copy this point. -5, 3/4 pi. So we're going to go to 3/4 pi. That means we're going to come all the way over here to 3/4, and then we're going to go -5. So we're not going to go from the origin toward 3/4. We're going to go in the opposite direction. So 1, 2, 3, 4, 5. So that's our first representation. We should be able to do 3 more easily. Let's do another one with also a -5. So we got to the 3/4 pi by going this way. So if we head in the clockwise direction, that would be -5 pi over 4. So -5 pi over 4. All right, now our other ones, we're going to have positive 5s. So that means we want to get onto this red line heading toward that directly. If we do it in the positive direction, we'd come all the way around here. So that would be 7 pi over 4. And then the quicker way to get there would be the negative angle in the clockwise direction, -pi over 4. Okay, I think that's enough for this lesson. There will be a homework assignment on webassign.net. In class, we're going to do some odd problems. What do I have listed here? 5, 7, 9, and 11. 5, 7, 9, and 11. We're going to do those out of the textbook. If you want to check them out, the online textbook you can use through WebAssign. And of course, all of the answers to these will be on calcchat.com. If any of them have a red number, we can watch the video on calcview.com. All right, I hope you enjoyed the video.